Welcome back to our continued discussion of query languages with spatial querying facilities. So if you recall in last three videos, we first covered the notion of queries and query languages, and then we introduced SQL. We first talked about data definition language to show you how to create a table, and simple data manipulation language statements like insert to populate those tables. And then in the last video, we got into select statement, and we saw how to retrieve data from single tables using different clauses. And we went through select, from, where, as well as group by and having, at least 5 different clauses. Okay. But the focus was to work with a single table, and we saw a number of queries which could take a table and retrieve subset of rows or subset of columns, and could do even some statistics. So first, the good news, if you mastered that material, then you know as much SQL as probably 90% of the people in the industry, because most of the people in industry, they come from programming background, whether it's Java, Python, Visual Basic, or COBOL, and they are very used to loops and simple variables. So they like to loop through an array and so on. So they often use single table queries. Okay. But SQL can do a lot more, and in fact when you see code which has nested loop, each loop going over a separate table, those are opportunities for you to improve performance. So if that code is running slow, then you can do a very simple thing, something called table joins, which is what we will learn in this particular video. Okay. So let me first introduce very simple multi-table query using 2 tables. And then we'll get a little more ambitious and try more than 2 tables. Okay. So our goals would be to first look at a multi-table SQL query, specifically 2 table, and try to understand its output, and also understand why you may need more than 1 table. Okay. And then we'll also talk a little bit about composing such queries. So if you were given an English question, then how do you determine how many tables are needed, right? Do you really need 1 table or more than 1 table? And we'll show you at least 2 different styles of doing that. Okay. So with this, let's start with this very simple query, which is asking you for capital cities, okay, which is here in purple. So we are asking for capital cities and populations of countries, and there is a condition here. Okay. So when you look at the country table, which is shown right here, so you can try to see that GDP or gross domestic product is available here. Right. So for each country, we can put a condition in the where clause and figure out which countries have GDP above $1 trillion. Okay. Population, you could also find that in this table. There is a population column, and we could list it there. Okay. But what about capital cities? So if you look at this country table, I don't see any information on the capital city. Right. So where does this come from? So one answer here would be to look at other tables. So do we remember the other tables like river and cities, and do you remember which of these tables may have this information, right? So probably your natural guess will be the city table, and you can quickly recall this city table had many columns, including this capital column. Okay. It also had a country column. So between these 2 columns, there is information about the capital city of a country. But in order to pull this together, you will need both tables, because now your query is asking some things from one table and other things from other table. Okay. So we'll need to learn how to work with 2 tables, and in SQL framework there is an abstract operation called join, and what that essentially does is to allow you to put 2 tables together. Okay. So in order to understand join, you may want to first look at a more simpler operation called cross product. Okay. So what cross product does is to allow you to take all combinations of rows in one table and rows in another table. Okay. So if you simply listed these 2 tables, city and country and city, in the from clause, then it will give you all possible combinations of rows. So in the city, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, and country you have roughly 6. So simply listing the 2 tables will give you 9 times 6 or 54 combinations, right? But as you know, many of these combinations won't be interesting, right? There is no point pairing up a city with a country that it doesn't belong to. Okay? So we are going to pare down those 54 pairs, and we only want pairs where this city belongs to a specific country. So in order to do that, you can attach a condition. You can essentially match the country name. So country table dot name should be matched with city top table dot country. Okay? So if you put that condition, something of this kind, so you say, well, match the rows in city table and country table, but there is a condition that the country name should match the city's country. Okay? If we did that, then many of the irrelevant pairs in that 54 will go away. Okay? And we will only have the relevant pairs where the cities will be matched with their own countries. Okay? We will still have to do more work to get rid of non-capital cities. Okay? And that you may want to do via this condition. So we can in addition say that on the city table, make sure the capital column is yes. Okay? So with these two conditions, now we have pulled in the capital information from the city table and put it together with country table. Okay? So once we understand this logic, then we can start to compose this SQL table. Okay? So here is the query back, and this is the kind of result we want. And here is your start of the SQL query. So we first say, okay, we need two tables. In order to answer this query, one table is not sufficient. So we need country table and city table. We are also putting aliases here because we are trying to reduce typing. Okay? In the result, we only want two things. Like you said, the city name and its population, and rest is in the condition. So in order to combine the two table, we put this condition which matches the country column in city table with name column in the country table. Okay? So what else do we need to do here? So first, we haven't checked for GDP, right? So we need to put the, some condition on GDP, and we hadn't tested for capital. So those conditions come in. Okay? So this kind of shows you a simple situation where we are using two tables. We are matching up the rows of this table using a condition which spans columns of the two table, and this is called the join condition. Okay? Most common join conditions are equality. Okay? And then we are putting other simple single table conditions to complete the query. Okay? Great. So this hopefully gives you a sense of how to even read a multi-table query. Okay? So suppose if somebody gave you this SQL statement and they want to ask you what will be the output, then in some sense you can revisit the discussion we just had. Okay? So in order to interpret this query, you read it in a slightly different order than it is written. So essentially you start reading it from the from clause, not from the select clause. Okay? You start from the from clause, and from clause has if it has multiple tables, then you first form combinations of rows from those tables. Okay? So this case you may have 9 cities, 6 countries, you make 54 combinations. Okay? Then you go to where clause and you apply this test on all those pairs and throw out any pair which doesn't meet the condition, right? So a lot of 54 pairs will go away because the country name will not match the city's country. Okay? Then further pruning will happen due to GDP and capital. Okay? Now for the remaining rows or pairs, we are going to go to select statement and pick out city name and country population. Okay? Great. So this gives us a feel for how to read multi-table queries. The big next question is, how do you compose one? Okay, so we are going to talk about this other aspect where we'll think about how do you compose one. Okay? And again, in general, select statements can be complicated. So the next heuristic I am going to give you is not going to apply to all like nested and so on, but it will apply to a very common family. So if you at least start with single block select statement, these meta questions or heuristics will help you. And at this stage, if you can master that, that will take us quite far, sufficient for this course. Okay? And with more experience, you will master the nested query. So here are the 3 meta questions. We always begin with the from clause. Okay? And in from clause, your meta question is which tables are needed to answer a query. Okay? So in our schema, there were 3 tables, country, city, and river. So we will go through those tables one by one for any query at hand. And you ask, do I really need all 3 of them, or could I get away with 2 of them, or maybe some cases even one table is enough, right? So you start with that. So once you have narrowed that down, then the next question we ask is the following, how are these tables combined? Most likely, okay, most questions posed to relation databases, they try to combine matching columns from the two tables, okay. So if you remember the schema, just like we saw between the city and country, there was a common column which was the name of the country, right? It was in both tables and you can match that. And again, if you remember, between the river table and country table, again we had a shared column. Every river had country of origin, okay. So usually in a properly designed databases, the second questions can be answered very easily. So you basically look at the two tables and see if there is a matching column. If it is there, you use that, okay. And this will take you quite far. These are the most common queries. Once in a while, the conditions are more complicated than that, and this course will probably not need it, okay. The last question has to do with the use of statistics, okay. So once you know which tables are needed, how you join them, then you ask the following question. When I am looking at the rows in the results, how do they correspond to the rows in the tables that we selected? Is there a 1-to-1 match? Or am I forming groups and doing statistics, okay? If there is a 1-to-1 match, then all you need is select from where, maybe order by, okay? You don't need group by and having, and your life is simple, okay? However, if we are forming groups and we are doing statistics, then you need to, consider group by and having. You ask how many groups are there. Is it like a single group? Is it a global statistics? Then you can still stay with select from where order by. But if you are forming multiple groups by continents or by city names or something else, then you do need group by, and then possibly having if you are eliminating some of them. So let's exercise this heuristic with one query. So here is an English query. It is asking for name and population of capital cities of the country where this particular river originates, okay. So in this English query, I could pause a couple of seconds, try to again think about in our schema, we had city table, country table, river table. Which of those are needed, okay? And again, in this English query, it will give you some clue. Either there are conditions or there are something we want in the result, and then only few, specific table has that, okay? So as you start analyzing it, okay, you start seeing river, right? So St. Lawrence River, and that will probably give you a hint that river table is important, okay? And then you start seeing country, okay? Now country information is there in multiple tables, so you have to be careful and see, do you really need country table or not? Maybe you can get away with the country information in river table or the city table, okay? If that's the case, we don't need country table, but if that's not the case, you will need the country table, okay? And you also see this capital, and if you remember in the previous query, capital information was only in the city table. It was not in the country table, so you probably need the city table, okay? So again, you want to go back and check the columns of these tables and see which ones you need, but possibly in this case, we may need all three, okay? All right, so that's question A, which tables are needed, okay? So once we have answered that, then we look at second question. How do we combine the tables, okay? And again, in order to do this in SQL, usually we combine two tables at a time. You pair them and then you add one more and so on, okay? So when you look at these tables, you will notice that city and country, we know how to join them, right? Because city table did have a country column, and country table had a name column, and they were matching. So you could start there, you could match them, city.country equal to country.name, okay? And also we know that river table has a country column for the country of origin. So you could use that column to combine river with country. And with these two conditions, you would have combined the rows across three tables, okay? So here river and country, and then country and city, okay? And then the last question is asking about, are we doing statistics? So again, you can scan this English question and see, do we have notions like groups or statistical functions like minimum, maximum, average, sum? And as you scan this, we don't see any of those grouping, aggregate or statistical words. So chances are, here the answer is no. So once we know these three, then we kind of know that we don't need group by, we don't need having. In this query, select from where are probably essential, and we don't see any sorting request either, so probably we don't need order by. Okay. So you already got a template, you got select from where, and for at least one clause, you already have all the information, and try to think about which clause is that. Okay. So for example, question A lists all the table, and that's your from clause. Okay. So now you can start composing the text starting from the from clause. So here is the from clause where we listed all the three tables. In the where clause, we can put in the join condition. Okay. So these join conditions now help you combine the table. So second question and first questions are used, and now we can fill in the rest. Okay. So one part is to say that what's in the result, and this is saying we are asking for the name and population of the city, right? So name and population of the city, CI is alias for the city. Okay. What else is missing here, right? So we combine the tables, we are getting name and population. Now you compare this code with the English one and say, are there further restrictions? And looks like there are. We are not interested in all cities. We are only interested in cities which are capital. So we'll need to test that capital column inside city table. And also we are not interested in all rivers. We are only interested in a specific river named St. Lawrence. So you are going to add these restrictions. You're going to say rivers only those where the name is St. Lawrence, and cities only those which are capital. Okay. So the three basic meta questions, they give you the bulk of this query, and then you work through and compare your query with English to fill in rest of the details. So hopefully this gives you a flavor of how to compose query, and this works very well if your query can be represented as a single block. Again, if you are into generality and so on, then there are other queries where you need more than one block, and over there you will have to break it up, and for each single block you could use these meta questions. Okay. But if you look at from pragmatics, vast majority of the queries that people write are single block, and using single block you can do a lot, because you now have this capability of joining table. Okay. In fact, theoretically, when the relational algebra was first proposed by Cod, he even said that all you need are three relational operations called select, project, and join, and all three can be done in single block select statement. Okay. So the first operation is select. All it does is to subset rows, and you remember the where clause allows you to subset rows. Okay. Project is subsetting columns, and your select clause allows you to do that, and the join is combining tables. So this single block query is very powerful, and you can do a lot with this. Okay. Chances are you are not going to need a whole lot more. Okay. But as you get experienced, you will find situations where you may need to write multiple single block queries and combine them either using set operations like union or intersection, or nesting. Okay. So we'll give you at least a flavor of nesting, but as I said, this single block multi-table query, if you can master that, then you would be ahead of 90% of the people in the industry. And using join. Okay. So joins is an operation which is very common in relational algebra, but it is missing in the traditional languages like Java, like Python, right? They don't have this operator. In fact, they don't have a lot of set operators. So if you can understand and master join, you are ahead of the game, because most people in industry, they came from this procedural language, and for them it's intuitive to loop through a table, but it's not natural for them to combine two tables using a join. Okay. So they often would go and do a nested loop, one outer loop on one table, inner loop on the other table, and that tends to, it can get the job done, but if the tables are bigger, they tend to be very inefficient. You fetch a lot more data from the database than it is needed. In contrast, if you wrote queries like this, where you're using join across multiple table, then your database server is able to see that, and it eliminates all the irrelevant data that your application doesn't need. And then your applications will scale better and run faster. Okay. So with this, having said that, let me at least show you what is beyond this single block. And one common thing is nested queries. And your chances are, again, you will see this in application code, but primarily because a lot of people have done nested loops in Java and Python. When they come to SQL, they keep doing that, right? And it's okay for the first prototype, but it can have scaling issues. But nonetheless, let's look at one of them. So here is another English query where we are looking at countries where gross domestic product is greater than that of Canada. Okay. So one way to write this query is to decompose it into two parts. You can see a natural nesting here. So you can first find out the gross domestic product of Canada. Okay. Let's suppose somebody gave you that number, okay, and hypothetically let's say it's $1 trillion, right? So if I had that number in hand, then this query becomes very simple. It's like a single table query. You go through the country table and check if the country's GDP is higher than 1 trillion, then you put it in the result, otherwise you let it go, okay. So your logic may look something like this, where you're going through country table and you're checking GDP greater than the trillion, okay. But since we don't know that number, we have to go look up the value of GDP for Canada. You could use another query to go do that, and here it is, okay. So in order to find GDP of Canada, you could write an inner query, and you say, well, go to country table and find the row where the country name is Canada, find its GDP, and use that value in comparison for the outer query, okay. So here you have seen the nesting way to compose. So the inner query, the green one, is a single block query. The outer one is a single block query, and in this case, fortunately, they are independent. So the inner query doesn't use any information from outer query table. So you can actually decompose it well and then put them back together as a nested query. So this kind of gives you a flavor of what is beyond a simple single block query. There is this kind of nesting. There is even more complicated nesting where inner query uses the table of outer query, sometimes called correlated queries, and those get pretty difficult to interpret and understand. So again, in the first course, we are not going to go there, but there is more on the horizon. As you get experienced, you will learn those, okay. So with this, hopefully we have given you a flavor of multi-table select statements. We started with just two table situation, where we also gave you some guidance on how to read two table queries. Starting from clause, you combine the rows of multiple tables, then you go to where clause and eliminate the pairs which don't qualify. If there are group by and having clause, you can go through the statistics, and then finally come to select clause and form the result, okay. We also gave you some hints on how to write a single block select statement which may use multiple tables. And you remember 3 different meta questions. You always first ask which tables are needed. So look at your English query and see either part of result or condition which tables are being referred to. Second, try to figure out how these tables are combined. So which columns are shared between at least 2 tables. So you come up with the join condition. And then finally ask yourself if there is any statistics involved. Are the rows in results representing individual rows in the previous step, or are they representing groups of rows? So if you ask those 3 meta questions, it will remove a lot of common mistakes from the single block select statement. And if you can reach there, you can do joins of multiple queries. You will be well ahead of vast majority of people in the industry. And then you can build on those skills later on to go and to situations where you need more than one single block queries. So this wraps up our basic introduction to select statement. Next time when we come back, we'll focus on spatial functions and operators, and we'll show you how to use that with select statement.